Hey there, this is Eric Keller for Entomology Animated. In this video, we're going to take a look at how I set up the shaders for the Rainbow Scarab Dung Beetle using Octane for Maya. And these are the textures that I exported from Substance in the previous videos. Now I'm in Maya 2018 and I'm hooking them up to Octane shaders and rendering with Octane for Maya. So a quick word about different rendering engines or rendering technologies for Maya. They all have their strengths and weaknesses. I'm not going to get all partisan about software because I think that's kind of boring. I like Arnold, I like Octane, I like V-Ray. I haven't used Redshift yet, but I'm probably going to use that for my next project just to kind of compare. Like I said, they all have their strengths and weaknesses. I'll talk a little bit about some of the features with Octane in this video, as well as some things that need to be looked at by the developers, I think. But you can see I'm rendering here right in the preview window, which is kind of nice. So I'm using the Octane renderer. And I just got some simple balls here with some shaders on them so I can kind of see the environment. And then I have a rotation on the beetle itself, so I can kind of scrub on the timeline and go to different frames and check out different views. So you can see here's the bottom. And if I go to the second half of the timeline, I'm actually rotating the lighting around the scene while keeping the models stationary. And it's just kind of a typical way to go about checking out the shaders as you develop them under basic lighting. And also what I've done, let's go back to this frame, and I'm going to go into the render settings. In this tab, I'm going to go to the environment, and I set up a second environment with an outdoor lighting scenario. So if I hide my little backdrop here, you can see I have kind of a forest set up, and I also have this, you can see reflected in this sphere is a big area light. So it's kind of similar to a flash and a macro camera rig. Could probably be bigger and more diffused, but I just went with the very simple area light just to get some basic lighting in there. And then I have an HDRI environment, and you can see it's a forest setup. So it's a spherical image of a forest. So I can switch between that and my studio setup. This is a studio setup, and I have a little backdrop here, which is just a plane with a bend deformer on it and a diffuse material. Sort of simulating a light box. Same area light though. So this project presented a number of interesting challenges when coming up with shaders for this insect. The one thing that is missing right now is hair. Bugs are very hairy. It may not look like it sometimes when you see a bug on the sidewalk, but if you look close, they all have hair. It's a very important part of the anatomy. And a bug model without hair is kind of like looking at a person model without eyebrows or eyelids. It just looks really off. So we don't have the hair yet. I'll put in the hair after I rig the beetle, but this is just mainly just developing the shaders. So it looks a little bit naked. But there's some cool challenges that this project presented. Number one, we have metallic and subsurface and sort of a blend in between the two. So metallic, of course, is going to be very opaque. Any surface that has subsurface scattering in it has a bit of transparency to it. So we go for highly reflective to somewhat less reflective to transparent and everything in between. So, of course, Substance was a huge help in allowing me to paint those qualities when I painted the metallic textures. And I exported all those textures from Substance and brought them into Octane for Maya and hooked them up to a single shader. So there's one shader for this entire bug. Okay, so that's a little bit of a lie. There's another shader for the eye. I chose to create a second shader for the eye just because the displacement on the original shader was a little bit too high, and it was causing kind of this to not look as reflective as I wanted. So I just came up with a separate shader for the eyes, but it's using all the same textures. It's just a variation on the original shader with some of the same textures. But we'll go into that in a little bit more detail later on. Let's zoom out a little bit so we can see more of this critter. If you've never used Octane for Maya before, I think it's pretty good. I want to highlight one thing, and that is that there's an entire course on Octane for Maya that is available on YouTube. So look up Octane Render for Maya Masterclass. I created this series for Otoy, It's got like 70 videos in it. It covers all the basics of working with Octane for Maya. So you want to check that out. All the videos are free, available online. And you might want to check out, I'm going to talk a little bit about the techniques, but not too much. But if you're curious for more information, the metallic material, the mixed material, specular, glossy, and diffuse material movies are worth checking out. They'll give you some more background on the various settings that I'm going to use. So what I'm using for the beetle is a new material, which is a universal material. So it's a single material that does all, it's an uber material basically, meaning that it does has all the features of the diffuse, specular, glossy, and metallic materials rolled into one single uber material. So it makes things a lot easier. I'm going to open up Hypershade here. Let's switch the renderer to viewport 2.0 just to speed things up a little bit. And you can see there's not a whole lot of materials in the scene. So let's take a look at our universal material in Hypershade. Okay, so you can see I have Vindex Universal. So this is a universal material. It's got transmission, albedo, metallic, specular qualities, plus IOR and all that kind of good stuff. So it's got basically all. Normally in previous versions of Octane, you could use either diffuse, glossy, metallic, or a specular material, or you could use the mixed material to blend those materials together. Now you can use the universal material. It takes care of a lot of that. And you can even use the universal material with the mixed material. So what I have plugged into these various channels are the textures that I exported for Substance in the previous movies. But if you remember, if I take a look, I'm going to select my Vindex model here, and let's go into modeling and check out the UV editor. So I have my textures set up as UDIMs. In other words, I have, this is the 0 to 1 space, this is 1 to 2, 2 to 3, 3 to 4, and so on in U and V. So in previous versions of Octane for Maya, it did not support UDIMs. Now it actually does, which is really cool. Makes things a lot easier. So you can see if I look at all of these together, I have essentially a 3x4 grid. So 3 up, 4 across. So I want to remember that for a second. So if I take a look at my universal material, I'm going to take a look at the albedo, which is what I'm using. Let's untangle this a little bit. Okay, so in the albedo, I have a color correct texture going at the albedo, and then plugged into the color correct texture is my image node. But I'm not using the standard image node. If I go to Octane Textures, Images, instead of using the Octane image texture, I'm using Octane image tiles texture. So if I create a new one of these, it's similar to the image node, except it has these tiles options. And this is how you take advantage of using UDIMs. So if I click on Add Tile, and then click on the folder icon, go into Source Images, basecolor.1001.png. So you want to use this naming convention. And then I'll add another tile, and I'll go in here and add the next one. And add a tile, and so on. So basically it's looking at this part of the name and using that to map it to the right texture space in the UV coordinates. You also have to set your grid size properly so that it takes into account all the UDIMs. So if I select my base color, you can see here are all the textures for the base color, and my grid size I set it 4x4, it could be 3x4, just as long as it encompasses all of the UDIMs in the geometry. So I've noticed a couple things. So it's great that Octane for Maya now supports UDIMs. What I think is unfortunate about this setup is the fact that you have to add all of these images manually. That gets really tedious, especially if you have a complex material. And in this particular material, I have, not just the base color, but also the normal map. I have to set this up. And you can save some time by duplicating the node and then just changing the name of the images, but still that's really tedious. And if you compare it to, say, just Maya's regular texture node, file texture node, in this case, if I select that albedo image and then set the UV tiling mode to UDIM, Mari, it's going to automatically detect all the UDIMs. And so that is about 10 seconds worth of work as opposed to something that could be, you know, minute of hooking up all these damn textures. So that's one complaint that I have with the setup. The other complaint that I have with the setup is that when I reopen this file, sometimes the textures become unconnected. They're still listed here, but I have to hit the reload button. So I have to hit the reload button a lot in order to get the textures to show up. So sometimes it loses the connection and this guy will render black. That's not good, because especially if I had a scene that had a lot of these textures in there. And then on top of that, batch rendering, it makes batch rendering a little bit iffy. If I kick off a batch render, even if everything looks okay in this, and my images get disconnected halfway through that batch render, that's a lot of time and energy that's lost. So need to make sure that they fix whatever is causing this to sometimes lose the connection, because that's not good. So generally speaking, when I start to set up a shader for a bug like this, I want to start with things like displacement and normal and get those things working first and then worry about the rest of it. So what I'm going to do is I'm going to create a new universal material and apply it to the geometry of the scene. So let's go into Octane Materials, Universal Material, and I'm going to select all the geometry, right click and choose Assign Material to Viewport. So we'll call this New Universal Mat. And if we take a look in the preview window, the geometry, you can see we have now a white bug. So I'm going to the attributes. I'm going to bring down the albedo to something like this. And I'm going to increase the roughness on the specular just to spread out that highlight a little bit to get something kind of metallic, just to allow us to see the details. So this is the geometry without any displacement on it. And I have subdivided the geometry at least one time within Octane. So if I select, say, part of the geometry and go in here to the shape node, open subdiv level, I've set to 1. So that means it's being subdivided one time. That'll help with the detail on the displacement. I usually don't need to set it higher than that. It can slow down the render, so you want to kind of be cautious subdividing your objects, especially if you don't need to. Let's take a look real quick at my render settings. I am rendering using Octane. And if we take a look at the kernel settings, I have set this to path trace, which is going to be more accurate than direct light, but a little bit slower. But this makes a big deal, especially when you start rendering metallic surfaces. So I'm just going to start with path trace. And I've set the max samples to 500, which is fairly low. If I take a look in the imager node, so here's the imager node. If I click on this, you can see that I have denoising turned on. And that kind of speeds up, allows me to render higher quality images with fewer samples, thus making it a little bit faster. I'm going to switch over to my passes, and under preview pass, I have the preview pass set to denoiser output. So you'll see a render for a little bit, and then suddenly it'll look nice and clean and smooth without some of this noise. And that's what the denoiser does. Okay, so back to the universal material. I'm going to go to in the material, I'm going to go to the settings and next to displacement, click on this little checker box, brings up create render node. We go directly to Octane displacement, create a displacement node, and it's hooked up. And then what we need to do is set the mid level. So when I created the displacement textures in ZBrush, remember a few episodes back, I exported displacement maps from ZBrush, and I had the mid-level in the ZBrush displacement map settings set to 0.5. So I'm going to do the same thing here. That means 50% gray in the texture is no displacement. Higher than 50% or higher than 0.5 is going to displace outwards. Between 0 and 0.5, it'll displace inwards. So I'm going to set that. And then I'll set the level of detail to 4K because they're 4K maps. And then what I did is I created, under image, I created that image tiles textures, and then under tile files, I added my displacement and hooked that into the texture for the displacement node. But rather than go through all that again, what I'll do is I'm going to find my displacement texture right here, which is this one right here. And I'm just going to connect the output of my displacement to the input of this displacement node here. And then if we take a look, as it starts to re-render, now we're starting to get some of that displacement detail. With displacement, I'm mostly interested on the effects of the silhouette, because a lot of the fine level of detail will pick up in the normal map. But this is clearly not doing anything. So if I go to the displacement node, you can see the reason it's not doing anything is because the height is set to 0.001. So after some testing, I found that a height of 0.005 gave me the displacement that I need. So you can see along here on the profile, it's got a nice amount of detail. But I also noticed that, and you probably experienced this too when working with Octane displacement, if I'm going to go to the kernel settings, and if I set the ray epsilon to say 0.1, you can start to see some tearing and some render errors here. And that can happen based on, if Octane's having trouble with the scale of the scene. 0.1 is always way too high for a ray epsilon. But if I set this down to like 0.001, those artifacts disappear. So double check your ray epsilon settings if you're getting a lot of errors in your displacement maps. So once I have the displacement worked out, I hook up my normal map. Again, these are the normal maps exported from Substance. And again, I'm just going to kind of reconnect the normal map here, which again is an image tiles texture with a whole bunch of inputs. I'm going to drag this over here and connected this to normal. And now you can see I'm getting a lot more detail. So now I have some detail going, I can start thinking about color. So what I did is I have my image tiles texture for my base color exported from Substance. It's going into a color correct texture, so I could just play with the saturation, hue, and so on. And I'm connecting this into albedo. Now of course we get something that looks like plastic. So we're not there yet. We need to have a nice metallic quality to the surface. So that's where that metal texture that we exported from Substance comes in handy. So the metal texture is a grayscale texture, and it determines which parts are more metallic by the light colors and which parts are less metallic by the dark colors. So I select it here. You can see there's the metal texture. So I'll expand on this in just a second. So let's move this over so we can see the transformation here. See if I can get this where it makes sense. So look at our beetle here. I'm going to take the output of our metallic texture and put it into the metallic input. And now you can see the metallic parts become metallic. In other words, they have some of that albedo color is being incorporated into the specular highlight, which is what it makes metallic, as opposed to the non-metallic parts, which have kind of a white sort of plastic-like highlight on them. So it's all about the reflection. So what's cool about this metallic texture is that now it turns the universal material into kind of a mixed material, self-contained. And I have to think about how the metallic parts reflect light versus the non-metallic parts, because I'm going to have different settings for those. So I'm going to set my BSDF model to GGX, which is the default. That's kind of one of the better models for simulating the shader interactions with light. I'm just going to leave that at that because it gets too technical otherwise. Let's leave the roughness alone for a moment. Let's just go down here to where it says dielectric IOR. So dielectric IOR controls the reflectivity, the index of refraction on the non-metallic parts. So if I increase this, you can see the non-metallic parts almost look like chrome because their index of refraction is so high. If I bring it down to say 1.1, we get something that's the reflection is not very strong at all. But you can see the metallic parts still look metallic. So let's set this to say 1.35 or something like that. It's not very scientific, but it kind of gets us a nice highlight on there without being blown out. Let's try a little bit higher. Let's try 1.5. That looks good enough for now. Then, of course, on the metallic parts of the surface, I also have this set of controls for the reflectivity of the metallic parts. And I have several modes here. So in this movie that I pointed out, in the metallic material, I go into detail on how to use these controls. So you can check that out. But essentially I have three different modes. You have default, which is just using the albedo color. The IOR plus color, which uses the albedo color, but also an index of refraction setting. So if I set this to like 1.8, and then I can tune it using this value right here. If I set it like 0.5 or 1 or 10 or whatever, you can just kind of eyeball it. You can see the effect that it's having. I just use my reference images and then kind of eyeball it to get it kind of close. So if you want to get super scientific, you can set this to RGB IOR and start looking up the index of refraction for specific metals. And then you can control the red, green, and blue channels of the index of refraction separately. But I'm going to leave it at IOR plus color because I think that's the easiest to work with. So let's go back into Hypershade, and what I'm going to do is I'm going to select my universal material. Let's just graph it, neaten up the graph a little bit. I'm going to select all my geometry here and then reapply this material. Okay, so let's go back to our material here. And as you can see, I have a texture for the roughness channel. Again, it's an image tiles texture. Set the color type to grayscale, since these are grayscale images, but that's what's creating this kind of dull parts and shiny parts. Again, painted in substance in the previous movie. So the subsurface scattering is on the non-metallic parts. And if I go into the render settings, and I'll go to passes here, and if I set my preview pass to subsurface scattering, you can see it's pretty subtle, but it's definitely there. So you can see on these edges, some bugs are going to have more of it than others. The beetle is kind of a moderate amount, but it's kind of subtle. But the main challenge, of course, let's go back to our denoised output so you can see the whole thing together. The challenge is, how do I get this on just these parts and not the metallic parts? Well, it's actually pretty easy. In order to have subsurface scattering in the universal material, you need to have some kind of transmission, some kind of transparency, so the light can actually penetrate the surface and bounce around. But of course, the metallic parts are opaque, so you don't want to have it in the metallic parts. So what I did is pretty simple. I took my metal texture, so you notice, let's clean this up a little bit, get these out of the way. I have two outputs for the metal texture. So metal texture is going into the metallic channel, of course, but I also have a second output going into a color correct. And the color correct is inverting the metal texture, and I've lowered the brightness a little bit. And I've plugged this into the transmission. So metal out, into color correct, inversion, output into transmission. And that creates transparency on any of the parts that are not blocked by the metallic texture. And then what I did is I went down here and I added a medium node. So medium nodes is what you use for subsurface scattering. So if you look in the medium nodes, there's just a few different types. We have absorption, scattering volume, and volume medium. I'm using the scattering medium. So scattering medium. Okay, so I have a medium node, and I have kind of a dark pink going into the absorption, and a light pink going into scattering, and I just kind of played around until I got something that I like the color of. That's how I determine those colors, mostly eyeballing. So they're going into absorption and scattering. I've set the phase on the positive side, which means that I'm getting more forward scattering, which I thought looked more like an insect type of translucency. I left the scale at 100, and I increased the volume step length to about 8. So this is kind of a quality setting. This is based on the scale of the surface. Lower scale is going to be more increased translucency. And then the phase, again, controls if it's back scattering on this side or forward scattering on this side. And that's how I got the translucency. So the next steps for this bug is I need to start thinking about getting some hair on him and put him in a scene with some more natural elements. So what I'm going to do next is I'm going to start rigging the bug, because I like to do that before doing the hair. So we'll talk about that in the next few chapters of this series. For more detailed information on my techniques, check out the Hyper-Realistic Insect Design video series that I created for the Gnomon Workshop.